So here in this problem, we need to determine the equation of a circle, and it's given here that the circle has a diameter whose equations are given by 2x minus 3y plus 12 equals to 0. And the equation of the second diameter is x plus 4y minus 5 equals to 0. And it's also given that the circle has an area equals to 154 square units. Now, let's find out the equation of the circle. Now, before beginning, what we'll do, let us specify the standard form of a circle. So let's say we have a circle with the radius r and the coordinate of the center is h, k. Then the equation, the standard form of the circle is going to be given by x minus h whole squared plus y minus k whole squared equals to square of the radius. So let's begin. Now here in our problem, we do not have the information about the coordinate of the center as well as the radius of the circle. But that's not a big issue. Here it's given here that the area of the circle, so let's specify whatever we have been provided with. So here we are given the area. So that's equals to, we know, 454 square units. Now what's the area of a square? We know that that's simply pi and r square. Let's call r as the radius of the circle. So pi r square, it's given here that this value is 154. So r squared will be 154 over pi, since we have to find out the value of r. So we'll take this positive square root on both sides. So that's the value of our radius. Now that we have the radius, our next goal will be to find out the coordinate of the center. So how do we do that? It's given here that we have two diameters whose equations are given. So let's say we have two diameters. So this be one of the diameter, and we always know that the diameter passes through the center of the circle. So one of the diameter has an equation. Let's say it's 2x minus 3y plus 12 equals to 0. Then we have another diameter. That diameter is also going to pass through the center of the circle, and that diameter has an equation x plus 4y minus 5 equals to 0. In a way, we can say that if we can solve these two equations, then they're going to give us the intersection point. So let's call it P. And the intersection point is going to be the coordinate of the center, because the two diameters is going to pass through the center. Or we can say that the two equation is going to have a common intersection point at the center. So let us begin. So here we're given the equation of the diameter. The first equation being 2x minus 3y plus 12 equals to 0. We're going to label this as equation number 1. And then we have the second equation of the diameter, which is x plus 4y minus 5 equals to 0. So let's call it equation number 2. We'll have to find out the value of x and y. So we'll start with equation number 1. We'll use the method of elimination here. The equation number 1, we'll keep it as it is. We have 2x minus 3y plus 12. That's equals to 0. Then we are going to take equation number 2, and we're going to make the coefficient of x in equation number 2 equals to the coefficient of x in equation number 1. That means we'll have to multiply throughout with 2. So now we get 2 times x is going to give us 2x. 2 times 4y is going to give us positive 8y. And 2 times negative 5 is going to be 10. So that's equals to 0. So what we'll do, we'll subtract the two equations. So subtracting means, so here we have 2 minus 2x, so that becomes 0. Negative 3y minus 8y, so that's going to give us negative 11y. And then we have positive 12 minus 10, so that means we have positive 22. So that's equals to 0. Negative 11y will be equals to negative 22. So solving for y, we get the value positive 2. Now that we have the value of y, what we can do? We can use the method of substitution to find out the value of x. Let's use equation number 1. So in equation number 1, we have 2x minus 3y, but we're going to substitute the value of y with the value that we obtained just now. So that's 2 plus 12 equals to 0. So we get 2x minus 6 plus 12 equals to 0. So negative 6 plus 12, so that's negative 6, positive 6. That will be equals to 0. 2x is going to be equals to negative 6. So the value of x comes out to be negative 3. So we have the value of x and y. So that means the coordinate of the intersection, that's going to be the coordinate of the center of the circle. So that is going to be equals to the coordinate of the center of the circle. Now we know that the coordinate of the center, that's h, k. That's the standard form. And we've obtained the value of h. So that's the x coordinate. So that's negative 3. And the y coordinate, which is k, that's 2. So immediately we can find out the value of h and k. So here we can say that the value of h is going to be -3 and the value of k, so that's equals 2. And we have also found out the value of the radius. The radius was square root of 154 divided by pi, which comes out to be approximately 7 square units. Therefore, we can now use the standard form of the circle. So we know that the standard form is given by x minus h whole squared plus y minus k whole squared equals to the square of the radius. So we get x minus h, but h is -3, so we're negative of -3, so that becomes +3. We have x plus 3 whole squared plus y minus k, so that becomes y minus 2 whole squared, and square of the radius, so we'll use the approximate value of 7 squared, so that's going to be 49. So this is the standard form of the circle. If we want, we can also further reduce this. We can expand x plus 3 whole squared to get x squared plus 6x plus 9. Then we can expand y minus 2 to get y squared minus 4y plus 4. So that's equals to 49. That gives us x squared plus 6x plus y squared minus 4y. So we're going to transpose 49 to the left hand side. So we have 9 minus 49, so that becomes -40, and we have -40 plus 4, so that's going to be equals to -36. So this is going to be the equation of the circle, and if we want to keep in the standard form, then this will be the standard form of the circle.